Okay. As Ricky has mentioned earlier, we are not going to install any new software. We're just going to continue to learn using the IDE available on Replit.com, right? Since it's free and available to everyone. And today we're going to talk about object-oriented programming, right? It's a concept in Python programming language, and it's also quite prevalent in some other programming languages as well. So it's a good idea to understand what actually is object-oriented programming, right? So as the name suggests, it is a programming, they call it a paradigm that centers around objects, right? What are objects? So in Python, we have classes and instances. Okay, I'm going to go through each of these. I'm going to go through each of these jargon individually so that we get a sense of what actually is object-oriented programming, right? So before that, let's talk about data types first, right? On day one, we mentioned that Python has several built-in data types like your strings, your integers, floats, and booleans, right? And if you recall, okay, let me just create a new repo. Today is day 5. Okay. Let's do a simple demonstration here. Okay, when we create a string, let's say a string like this, all right, and we try to use the type function, all right, and we print it out, right? Because this type function is actually going to return us the data type of this particular string over here, right? Let's run this, and you'll see that it is class str, right? So it's a string type. Now, they don't use the word data type over here, right? They use the word class instead. Okay, so to give you a good perspective on this, class means oh wow, thanks X for giving everyone the link. Class means data type, right? So what we're going to learn today is we can actually produce our own data type, right? We can create our own data type. Okay, not only the built-in data types, we can also create our own classes, right? So when I create an object like this, quotation mark, string, quotation mark, right? This is considered an object. Okay, let me just write this down. This is me creating an object, right? So the process of creating an object, right, is also called instantiate. Okay, now just going through some of the technical words over here. Instantiate. All right, why do they call it instantiate? Because it is also actually means creating an instance. Okay, an object is also an instance in Python. All right, now I don't want to confuse you too much with other programming languages because for other programming languages, they may have a different idea of what object is. All right, so for in Python, right, object is an instance. Whenever we create a new object, all right, and if we choose to assign it to a variable, we have instantiated one instance, right? We have created one instance. Okay, get the idea, right? Classes and instance. Okay, now let's move away from this and go back to the link over here. When we talk about classes, I want you to imagine this as a factory. Oops, my drawing for factory is not very good. Okay, that doesn't look like a factory. Okay, anyway, the idea is this, right? This is like a factory, all right? When you define your classes, all right, you are just defining the blueprint of it, right? Creating a factory of it. Have you produced anything yet? Right? The answer is no. You have not produced any instances or any object yet. Okay, to create an object, you will need to instantiate. Right? Instantiating a class will create an object of that particular class. All right, and why do we need to learn about object-oriented programming in Python? Okay, it has everything to do with the word inheritance. Okay, inheritance means you getting something from someone above, or not to say above, someone that exists before you. Like in our human world, inheritance is like us inheriting something from our parents, right? We inherited our hair color, maybe our eye colors from our father, or our lips color from our mother and stuff, right? These are all inheritance, right? So in Python, okay, when we talk about object-oriented programming, the idea is this, right? We want to create an object out of an existing class if possible, right? We don't want to create too many new classes, right? But we want to, in fact, inherit certain traits, all right, or attributes or methods from existing classes, right? So it promotes the idea of reusability. Okay, that means you have created one class, you can actually extend from there, right, to create more and more different classes. But the base class is always the one that's at the very top, right? The parent class, the one that we created in the first place. Okay, now let's not talk too far away from that. Let's just learn how to create a class first. All right. So to create a class, it is very similar to us defining a function. All right. Now, today I'm also going to take the opportunity to teach you guys on packaging as well. So instead of using the main.py, I'm going to click on files. All right. And I'm going to click on add file over here on the right, on the left. And let's add a new Python file called farm.py. Okay, essentially it is also a Python file, all right, but it is not the main one for the time being. Okay, and I'm gonna explain why I do this later on. Okay, just bear with me for a while. And now that we don't need this file anymore, we can close the tab. Okay, make sure that you're on the farm.py file, right? So let's take a look at how we can create our own class. Right, first thing first, we need a keyword, right? Like how you define functions, but instead of the word def, we use class, right? As the name suggests, you are now creating a new class, right? And when we create a class, we would need to use the naming convention of a Pascal case, right? What is a Pascal case? We always start with capital letters for our naming, right? So in this case, we are actually going to use an animal, right, as our class. Okay, once this animal has been created, we also need to have a bracket over here, right, and a colon. Okay, so this is me naming my class. Okay, and all of you should be very familiar by now. Once we have a colon, that means when we go to the next line, it'll be indented, right? There is an indentation over here. Okay, so this is the steps of creating a new class. Now, in every new class that you create, all right, you would usually have this method called underscore init, init underscore, all right, followed by the parameter of self. Okay, now I'm gonna take a little bit of time to explain what is going on over here, right? This method is frequently called as the constructor method. Okay, and this is always called when you are creating an instance, right? When you are instantiating this particular object, all right? This will always be called. And notice that I'm using two underscore in front and behind the word init, all right? These are called Dunder methods. It's a very Python thing because it's not very prevalent in other programming languages, all right? And I wouldn't go too much into Dunder methods for this course, all right, because it's a bit more advanced. But if you're interested, you can look up for it on the internet, right? It's called Dunder methods, right? Anything that starts and ends with a double underscore is called your Dunder methods, right? Dunder, it's kind of like a short for double underscore. All right, okay, so this is a constructor method. And always remember this, when you're defining a method, you will always have a self parameter. Okay, what is this self parameter? Okay, this self parameter refers to the object that you are going to create. All right, now at this point, it is not very clear, but I will explain to you later on. All right. So let's take a look at this. So when we define this constructor, we can now assign some of the attributes to this class, right? Attributes are like variables that are tied to this object. Let's say, for example, this animal, right? We are going to have a name, okay? And this name is going to be passed in by the constructor, right? So on my constructor, I will just put in another name over here. That means when I call the animal class, I will need to call the init name as well. All right. And I think I will need to put this in the main py to do the demonstration first. Okay, never mind. Let me just try this out. All right. I'm going to copy it over to the main for now because I want to run it and show you guys. All right, so let's say, for example, I have animal, and this is me trying to call the constructor method. All right, so animal bracket, right? This is me trying to instantiate an object, okay? And inside this object, we have said that to instantiate it, we need to provide a name as well, right? All right, and that will be the object's name, right? So let's give it a name. Let's say Francis. Okay, and this is us creating an object. And when we instantiate this object, we will usually want to store it somewhere, right? Let's say maybe, for example, I will store it inside a variable called animal1. Okay, I have instantiated an object called Francis inside animal1. All right, so now if I were to print out the attribute, okay, so this is the attribute, okay, and variable that's inside a class, we can just print animal1 dot name. All right, when I print this, I should be able to get Francis. Okay, and of course I can do more than just a name, right? I can also do self.age 30. Let's say all animal classes that I create will all be named will all have the age of 30. Okay, so let's say, for example, I create another animal. This time I call it Frankie. Okay, so when I print animal2 dot name, all right, and I bracket animal2 dot age, all right, I can print two different items, all right, this, and you'll be able to see that it's Frankie and 30, right? This is me trying to refer to a variable that is stored inside the object, okay? And remember what I talked about self being the object that is being created, all right? When you call this, when you're doing this instantiation, all right, this object over here, this is the self, right? That's the reason why when we refer to self.name, we're actually referring to animal1.name. Okay, and all methods will have the self as your first parameter. All right, so this is attribute. Okay, all right, now let's take it very slowly. Besides defining the attribute, we can also define a method. Okay, we can define a function inside this class. All right, and then I am just going to pass in self as my parameter, and this is going to print my name is, okay, let's use an F string for this. Self.name, right? This is referring to whatever object it is referring to and its own name, all right? And I am self.age years old. Okay, so when I've instantiated these two objects over here, I can now call the method of intro that belongs exclusively to this animal class, right? So I can do something like animal2.intro, all right, with a bracket to call it, and I run it. You'll be able to see my name is Frankie and I am 30 years old. All right, same thing for my animal1. All right, my name is Francis, I am 30 years old. Okay, it will always be 30 years old because we assign the self.age to be 30. All right, now, of course, If you want to pass in the age yourself when you create this class, you can also put in self.age equals assign a value of age, then you pass it in as your parameter. Okay, that means when you create this animal, you need to pass in one more information. All right, so let's say Francis is about what, 39 now? Okay, Frankie is 30. Okay, so when I create this and I do an intro of both of them, okay, you'll be able to see that there are 2 sentences right now. Okay, so this is a method. All right. Okay, let me take a look at the chat before we move on to see if there's takes no argument. Do we have optional input to class? All right, so for class, if you are creating the base class, which is the parent class, there is no need to put in input. Okay, Shaoqi, it gives type error, takes no arguments. Okay, make sure you're in it. When you define your underscore in it, you need to put in your self, name, and age. Okay, all right. Now this is me creating an animal class. Okay, now the next step is to talk a bit about how do we extend from this. Okay, now that we have the base class, we can actually create more classes out of the base class. All right, what do I mean by that? Okay, let me just throw all this away. All right, so I now have a new class. And because we're going to do a simple farm.py over here, right? In a farm, there are a few different animals, right? We have chicken, cow, duck, and stuff, right? So let's create a chicken first. Right, now this chicken class, as we all know, is actually a children of the animal class, right? So we can bracket animal over here. This is me telling the computer that, hey, this chicken class is actually based off of the animal class on top. All right, and when I do this, okay, I can simply just put a little pass over here. That means this chicken has nothing inside. All right, I just call the computer to ignore this. All right, why I want to do this is because if I do a, let's say, chicken 1 is actually the instance of chicken based on the name and age of, let's say, Gu and 20. All right, and I run this. Okay, you will see that there is no error, right? That means an instance of chicken has been created. All right, and if I were to do chicken 1, oops, wrong spelling of chicken, 1.intro, you'll be able to see that my name is Gu and I am 20 years old. Now, why is it possible that even though I do chicken at pass means I just get the computer to ignore that there is something over here, right? To move on, okay? Because if I don't have the pass over here, the computer think that, hey, you have a colon and there is nothing inside, something is wrong with this code over here, right? So I just need to tell the computer, hey, it's fine, I just need you to pass, all right? Now, this works because a chicken is essentially a children, okay? We call this the children class, all right, of the parent class, okay? So basically, I'm inheriting everything from animal, okay? All my name, my age, my intro as a method, everything is being inherited to chicken, okay? So this is the beauty of inheritance. Now, what if I want to make some changes, all right? So chicken is a bit different, right? Chicken, I want to have a new function called quack. Excuse me. What is wrong with your code? Let's take a look. Okay, I don't see anything wrong with your code X. Okay, maybe I'll look into it later on. Okay, and I don't. Yeah, you need to tell me what is your error so that I know what to look out for. Okay. Anyway, let's come back to this, right? Let's say, for example, I want my chicken to have additional method. Okay, so I now define a new method called what is the chicken sound? Oh, quack or cluck. Quack is actually duck, right? So cluck. So what I'm going to do is I'm just going to print cluck, cluck, cluckadoo. And maybe I'll just write my own name. I am self.name. All right, F string, make sure it's F strings. All right. Okay, so this chicken, instead of just doing an intro, I can now do a chicken one dot cluck. Okay, notice how I always have the self when I define my methods. Okay. All right, cluck cluckadoo, I am Goo. All right, so this is the chickens method. Now, if I were to do a simple animal, okay, if you remember animal, okay, maybe friend at 25 years old, okay. Do you think I'll be able to do animal one dot cluck? All right, let's try out. No, all right, because if you refer to the animal, there is no such method as cluck. However, if you refer to the chicken animal, all right, there is such a method called cluck, right? And this cluck method is only exclusive to the chicken class. Okay, now what am I trying to do over here? Okay, a children can have all the methods of the parent, all right, but the parent does not have the methods of the children. Okay, it makes sense when you think about it this way, right? You inherit something from your parent, all right? It doesn't work the way where your parent inherits something from you, right? So that's how it works in Python, right? You can inherit something from the parent, but not from the children. Okay? All right. So let me just address to some issue before I move on. Oh, okay. Dunder init takes into self name. Chicken Goo 200. Yep. So you gave Goo 200. X, look at your define init properly, right? It only requires a name, right? But you're also giving 200 as an argument. So you're giving more argument than the constructor is required. All right, so that is the error. Would chicken self name override the parent's name value? Okay, now the chicken self name will not override the parent's value if I have not done anything to it. Okay, now, however, all right, the next part is the overriding the parent's attributes. Okay, now, if I were to define a new dunder init in this chicken, all right, this will officially override the animals init. Okay, now let me show you what happens here. Okay, let's say I no longer need self.name and self.age. I just call self.power. Okay, equals to 9,000. Okay, now when I try to instantiate chicken based on Goo and 20, let's see what happened. Okay, sorry. The cluck needs to be removed first. Okay, you will see that, hey, now chicken only takes in a self argument. That means I don't need any additional argument at all. To instantiate a chicken, I just need to do this, right? This is me overriding my parent. Okay, I override the entire attribute. If I do this, you will realize that the name and age will no longer be available as well. Okay, let's try this out. Okay, I run this. Okay, see, the chicken object does not have the attribute name. Okay, because I have not defined a self.name in my chicken animal. In my chicken class. Okay, so even if I call it a children of animal class, I have overwritten the constructor, right? Remember, this is called the constructor method. Okay, the attributes are completely different right now. Okay, so this is overriding it. Usually we don't want to do that because we inherit it for a reason, right? We want to use certain attributes of this particular class. So what we usually want to do is we want to extend, okay? Extend the parent class. All right, extend means I want to add additional attributes on top of the current attributes. Okay, how do we do this? All right, to do this, we need to use the super function. Okay, let me do this. Okay, so self.power, I will still leave it here because this is the extension that we want. All right, let's say, for example, I want to inherit. Not only do I want to add this self.power onto the chicken class, I still want my name and age. That means I need to extend from my parents' attribute, right? So let's call this super bracket, right? This is me calling the super function, right? Dot underscore underscore init underscore underscore and then bracket. Okay, now what's happening over here is this is me calling this constructor method. All right, so I'm passing everything over here to my chicken. All right, and when I say I want to do that, I need to meet the current initiator as well. Right, so if this initiator requires a name and an age, I need to pass in my name and age here as well. Okay, and it depends on whether you want it to be fixed. All right, if you don't want it to be fixed, you want it to be passed in as an argument, then make sure your constructor will also need to take in a name and age. Okay, so that the squiggly lines will go off. All right, so now if I were to do another define, all right, let's say cluckadoo, I am Gu, and my power is self.power. Okay, so when we do this, all right, we do a chicken, we need to pass in our name. Okay, let's say maybe Gu and our age, which is 99. All right, let's pass this in. You'll see that my method has now upgraded to cluckadoo, I am Gu, and my power is 9,000. All right, so this power is only available in the chicken class, right? Because this is an extension, all right? The normal animal class will not have this attribute of power. Okay, so you get the idea of why do we need classes. Okay, if some of you have actually played some form of video games, you will realize that most of the characters are actually made up of a base character, where you have your HP, your MP, and all the regular stuff, right? And then we extend from it to create additional children classes, right? Where some of you can be enemy, right? Enemy also have HP and MP, right? But the enemy will have something extra, like maybe some auras, some special methods, all right? Then we also have like boss, and you have your own character, right? The main character, and then maybe you have the other NPCs, okay? And all of them have their unique attributes and methods, okay? But they're all built from the base idea of HP and MP, right? The base base class, okay? And then even if you're the main character, you can further branch off to like maybe a different class, right? You have your gladiator class, you have your mage class, and different class have different methods, right? Where you can cast spells or you can use different skills, right? So this is the general idea of object-oriented programming. Okay, so let me just take a look at the chat before we move on to make sure everyone is clear. Can the arguments that you pass in can be in any orders? I don't think any order. All right. So yes, when we do this, we are actually identifying the positional arguments. All right. What do I mean by positional arguments? That means the first argument must be a name. The second argument must be a age. All right. So let's say, for example, if I reverse this, let's see what happens, right? It will now tell you that my name is 99 and I am Gu years old. Okay. Now it wouldn't break this class because we have not tell the computer that, hey, this name must be a string, this age must be an integer, right? So it actually works, but it doesn't really make sense, right? So let's just fix this. All right. Okay. Age equals 99, name equals to Gu. Yes, Surya, that is also possible. That's what we call the keyword argument. That means you specify what is the name of the parameter followed by the name of the value. Okay, so Surya, that's correct. Why we have to pass on the argument for name and age when we already inherit from the parent class from the top? Okay, let's take a look. All right, when you're trying to instantiate a class of chicken, that is chicken itself, right? Not the animal. Okay, so when we do this super init name age, we actually also need to pass in a name or an age, right? So to pass in this, we need to pass in the argument. Okay, you need to realize that chicken one and animal one, they are two different objects. All right, animal instance and the chicken instance, they are different. All right, that is the reason why you still need to pass in a name and an age. Okay, why did we use super instead of define init? Okay, so I'm not sure if I should pronounce your name Jacqueline or Jocelyn. All right, so the idea of super is to extend the attributes from your parent class. Okay, now what happens here is, remember just now when I mentioned, if I don't have these two lines and I just do a define init self.power, this is me overriding the constructor of my parent class. That means your self.name, self.age will no longer be available. All right, it will just be self.power and that's it, because you have a new constructor now. Okay, just because you write chicken bracket animal, right, doesn't automatically inherit everything over. Okay, and even if it does, when you define a new constructor, you have overwritten it. All right, just like how, let's take for example this. You take someone else's a check. Let's say for example a check. Okay, initially the value is 900. Okay, then you take it over and then you replace it. All right, and then you put only 200. Okay, the old value of 900 will be replaced, right? And you only have 200. Okay, exactly that. Okay, however, if we do extend class, you are basically telling the check that, hey, your 900 is still there, and now I want to add something on top of it. All right, so maybe add 1. Okay, something like that, right? You're just extending the current class. Okay, you're not replacing it, you're just extending from it. So all your previous age and name will still be available in your chicken class. All right, this is an extension. You need this line over here to extend it. All right, this super over here can actually be replaced by the class name itself. All right, but I actually like to use the word super because it sounds super. Yep. Okay, guys, make sure to not delete your main.py, right? Remember just now I did a farm.py. Okay, I realized I made a mistake. I need to actually run the code on main.py. That's how Replit works. So make sure you code on main.py for now. All right, later on I will copy it over to the farm.py. Okay. Devi, you need to paste me the entire code, or else I wouldn't be able to understand what's wrong with your code. If you put the class name instead of super, is it possible to accidentally inherit from a random incorrect class? Well, there is a chance. Let's say, for example, you have more than one class, like say animal and some other things, and then you refer to, let's say, different class, like maybe Power Rangers. Then you inherit from the Power Ranger class instead, if you have a Power Ranger class. Okay. And in fact, you can inherit from several classes. Okay, but I'm not going to go too deep into that. All right, I just want to introduce the general idea of classes, and I'll leave the rest of the exploration to you guys. Okay. Your init, all right, you need to pass in your name and age as well. Okay, if you're gonna tell your computer to use this super init, and this super init has name and age in it because the previous class animal has the constructor of init, name and age. Okay, you need to pass in these two arguments. All right, and because you need to pass in these two arguments, your chicken, when it's being constructed, need to pass in your name and age as well, unless you want to have a fixed name for your chicken. Let's say maybe Paul and the age of 35, right? If this information is fixed, then you don't need to have your arguments anymore. Okay, Anika? Okay, make sure your parameters and arguments are properly declared. Okay, now I'm going to talk about one more thing before we explore packaging. All right, so let's say, for example, when you do this chicken class over here, all right, and you want to have a default value for a certain variable. Okay, let's say, for example, if your chickens have a default age. Okay, the word here is default, right? That means a value that is always there, even if there's no value being provided. Okay, how do we do that? All right, we can simply put, an equal sign over here and then put in the number that you want. Okay, this equal sign, all right, is me trying to assign a value to the argument. So when I create an instance and I did not put in my age, all right, the age will automatically be 100. Ta-da, I am 100 years old. Okay, so this is how you put in default values for your argument. However, all right, you cannot put in default values in this manner where you identify this first, and then this one does not have a default value. Okay, now why is that so? If you look carefully, non-default argument follows default argument. Okay, so you cannot have a default argument like this before a non-default argument. All right, when I run this, you have an error. Okay, what do I mean by non-default argument? Non-default argument means I need to pass in a value that has no default value. However, in front, I have an argument that has a default value, right? This does not work, okay? Always make sure the variables, all right, or the arguments that you want to have default values are at the back, at the very end, okay? All right. So this is how you do it with default value. How do we keep all this data all in memory? How do we link and store the data in a database for searching and processing? All right. So Ern, to answer your question, currently all of this is stored in the cloud, right? So all this code will automatically be saved and we can run it. Now, if you want to talk about database, right, and backend, you need to stay tuned for Mr. Eric's lesson on Wednesday, I think, or Thursday, where he talked about DynamoDB, all right, on how we can store information in cloud database, okay, or by AWS, and how do we actually retrieve it, okay? Yeah, at this current moment, we don't actually have to explore all the nitty-gritties first, right? So now we're just talking about object-oriented programming. Okay, so, all right, now that we have this, okay, I am going to do something fun like this. I'm going to copy everything over to my farm.py. Okay, copy everything over to farm.py. Okay, I'm gonna explain why I'm gonna do this. And I'm gonna create a few more classes, all right? Instead of just the chicken class, we are going to have a, sorry, class. Let's create a duck class. Okay, and a duck class should have, okay, I want to have the exact same name and age, right? My duck doesn't have power, it's perfectly fine. So I don't have to define the constructor method again, right? I just need to construct a new method called quack. All right, and then I'm just gonna print I'm a quack all day and all night, like duck. Okay, and then I am also going to, oh, I should actually extend this. All right, let me tell you why. Because I need to tell the computer that my type is a chicken. Okay, fine. And then my duck would also have the type. Okay, let's say a dunder in it. And yeah, I need to pass in myself, name, age. Because why? Because in my super, I need to put in my name and age. And this is of self dot type. This is a duck. Okay. All right. Then I am going to class cow. Let's create a cow out of animal. Okay, define underscore, and then, oops. Super dot and then self dot type equals to cow. Sorry. Okay. By the way, Vincent. All right. To store information, usually when we use variable, we say that it stores information, right? But the actual idea, all right, the actual definition in computer science is not that the variable is storing the information. The variables are actually pointing to a memory to an address in a computer's memory that has this particular object stored. It's a bit more convoluted, all right? But yeah, for simplicity's sake, right? In layman term, we usually say that a variable is storing the information. But in actual fact, all right, the information is stored in the computer's memory, and a variable is simply a pointer at that particular address. Okay, imagine, yes, you can use ID to find out the memory's location. Imagine the computer's memory have a lot of different houses. All right, and when you instantiate an object, let's say for example, I have a string like this, it is actually in one of these objects, in one of these houses, right? And they have a different address. And when we assign a variable to it, we are actually pointing at this address, right? And that's the reason why when we refer to it, we can get the piece of information. Okay, but that is not very important when it comes to creating a program. All right, it is important in your understanding of computer science if you're interested in computer science in the first place, but not very important if you just want to come up with a program, right? This is a bit more on the nitty-gritty end. Vivek, class public, I think that's more for Java. I think in Python, we don't really call it public classes. Yeah. Okay, sorry. I was just doing this cow thingy. All right, define move self. Okay, I'm gonna print. I work like a self.type. And then I'm just gonna do self dot. I'm just gonna do move. Okay. So I have 3 classes right now: cow, duck, and chicken, all from the animal parent class, right? So what I'm going to do over here is I'm going to show you the idea of packaging. Okay, so on my main.py, it is currently empty. All right, so if I were to package this in a farm.py, if I want to use anything that's inside the farm.py, oh no, I click on the wrong thing. Okay, we can do things like import farm. All right, this is me trying to tell the computer that, hey, I'm gonna import this stuff from farm.py. And this only works when farm.py is in the same folder as your main.py. All right, or what we call the same directory. Okay. And once we have done this, now we can call something like, let's create an animal, right? For example, animal 1. Okay, to instantiate this, we need to do farm.animal. Remember, this is how we create an object, right? And this animal, as you can see, it tells you that, hey, it actually requires a name and an age. Okay, so we're just gonna do a name, which is, let's say, Po, and an age of 29. Okay, and now we can do animal 1 dot intro. Okay, it will say my name is Po and I am 29 years old. Now, why am I doing this? Okay, usually when you are doing a huge project, let's say for example to create a video game or some other projects, right, where you have different assets and stuff, you would usually want to define your other codes on a different file, right? So this is where I define all my objects, right? My classes and stuff, and this is where I use it. Okay, I don't see all my definitions, right? I only see it on my other package. All right, this will make your code easier to read, all right, and also makes it easier to debug when you find out a certain problem with your classes. You can just go back to the file that contains these classes and fix it here instead, right, without touching the main file. Okay, so this is also an idea of abstraction and decomposition. Okay, so basically is I hide all the things, all the behind the scenes in another file, right? So that it is not so confusing to read, all right? And it makes separation of information easier. Okay, let's see. Why do some use with farm dot versus import? Is there a benefit to either? There is. Okay, so there are a lot of different methods or different ways to import your package, right? You can import farm as F to change this name to F, okay, to make it shorter, or you can do this, right, where you can do from farm import star. But to be honest, I don't really recommend this because when you do from farm import star, you are bringing everything over. That means all your animal, your chicken, everything over. And what is bad about this, all right? This is, how do you say, it's polluting your namespace. Let's say, for example, if you have some other information that is using the chicken namespace, all right, when you bring this over, you will replace it. All right, you may have accidentally overwritten it. All right, so my recommendation is try not to do this. Avoid this at all costs. All right, However, if you just want to import certain classes or functions, let's say for example, in farm, you just need the animal, you can do this, right? From farm, import animal, and then you will call the animal function just like this, and it will be fine. Okay, because you're just importing the animal function and you know that you are not using this animal in your program. Okay, but when you do from farm import star, this is very risky because you are bringing in everything over. And if you are not very familiar with your package, let's say for example, you are importing from some other modules, let's say from random, okay, you never know what are the functions that's inside that clashes with your own function names. All right, so it's a very risky procedure. Okay, so my practice is I always import the module name. And then when I need to use a certain function or a class inside this module of package, I will just call it farm.animal. This will make sure that it will not pollute my namespace. All right, then make sure that every variable is perfectly separated from each other. Okay. All right. So, okay. How can I use the other Python files which is on a different directory? That is actually a bit more complicated. You will need a path finder, which is actually very complicated. Try not to do that, but eventually we will have to do it in a huge, when we're doing some huge project. All right, you will need to do I think you need to use a module called path. Right, you may need to explore on this. Okay, but for now, let's just assume that we are working on the same directory, right? Which is the case right now, right? So what other fun things I can do over here is I can import farm, and let's say I can have an animal list of, let's say, a cow, chicken, and duck, right? Now notice that I use my classes without the bracket. So if I do it without the bracket, that means I haven't instantiated yet, right? So what I can do over here is I can create another animal. Okay. Let's call this class list instead. Class list and animal list. All right. And I have this in empty list. Okay, so for I in range of 6, okay, I can create 6 different animals, all right, based randomly on the different classes available to me, right? Cow, chicken, or duck, right? I can just import random like this. Okay, let me drink water first. I have a sore throat. Okay, let me call a name list as well. Okay, because remember I need to pass in the name of my chickens, right? I need to do 6. So I have AB, I have Bob, I have Kate, I have what's the name that starts with D? Okay, Derek. Cool. I have Elon, that's 5, and I have Fran. Okay, I have 6 names over here. Okay, for I in range of 6, I can simply do a random.choice. Okay, choose from the animal list. Not the animal list, the class list. All right, and then once I've chosen a class that I want, I would then do a bracket pass in the name, right? Name underscore list square bracket 0, right? So what am I going to do over here is I am going to go through one of each over here and pass it in as the name of the class. Okay, and you realize that, hey, I also actually need to pass in the age, right? So what I'm going to do over here is I'm going to make things simple and remove the age instead. No, I actually need it for my intro. Fine. Anyway, I'll just do a random dot rent in, then maybe about 10 to 20 years old. Okay, I'll just do this, all right, and I'm going to get this instantiation to be saved inside the animal list. All right, so I do animal underscore list dot append. Okay, now it may seem a bit too long over here. So to make things easier to read, what I'm going to do over here is this random dot choice, I'm going to save it inside a variable called, let's say, temporary first. Okay, and once this instantiation has been done, all right, I have created a class, an object. I will just use animal underscore list dot append the temporary to put it inside the animal list. Okay, so what am I going to do over here is I will use a random dot choice to select a class first. Okay, and once this class is selected, I'm going to pass in the name list. All right, and actually it's not 0, it should be I because it's a for loop and it will change accordingly. All right, when it's 0, it's Abe. 1 is Bob, and so forth, right? And not only that, I will also pass in the age. Okay, and then what I'm going to do is I am going to get all of them to actually do an introduction. Length of animal underscore list. Okay, I should actually do this. Length of name list. Okay, and then I will just do a animal underscore list square bracket I dot intro. Okay, I'm gonna get each and every animal to introduce themselves. Okay, now there is a bit of squiggly line over here. That means there is an error. All right, so the error here is telling me that I don't know what is cow, what is chicken, what is duck. Okay, because cow, chicken, and duck, they are all from the farm.py, right? So we need to actually indicate it farm.cow, farm.chicken, and farm.duck. Okay. So when I run this, okay, it takes a bit of time. I should expect to see 6 different sentences. Why is it taking so long? Okay, so I have it, right? So I have Abe, it is also Fran, 15, 14, 15, 14, and 17. Okay, now if I were to print out each and their types, okay, let's say for example, I want to print, all right, I am a, let's say self dot, no, not self dot, it's animal underscore list square bracket I dot type. Okay, remember we have a type attribute for each of the animal, right? This is how we actually get them to print that I am a cow, or I'm a sheep, or I am a duck, or stuff like that. So let me run this, and you should be able to see that, okay, Abe is a cow, Bob is a cow, Kate is a chicken, Derek is a cow, Ellen's a cow, and Fran is a duck. All right, and we have 4 of them at 20 years old. Wow, okay. What are we storing in temporary variable? Okay, the temporary variable is just an idea of me temporarily storing the information on this, where I try to create a random object out of the classes. I can make this shorter by doing animal underscore list dot append bracket random dot choice name list and stuff. But that will make it very hard to read, right? Because it's very long. Okay, so in order to shorten it, I actually do a temp random dot choice class list and then bracket the name underscore list square bracket I and stuff. Now, if I were to make this even more readable, okay, I can even break this down into a variable of its own. Okay, so let's say for example, temporary class is equals to random dot choice class list. Okay, so this is me trying to tell the computer to select a random class first. Okay, once I've selected a random class, I want to make a temporary instance of based on the class that has been selected. I passed in my name. Oops, sorry. I passed in my name and I also pass in the age, right? Random.randin is just an age. Okay, and if I have this, I don't need the temp anymore. I just need to do animal underscore list dot append temporary instance. Now, is this easier to understand? All right, so at first I use a random dot choice to select randomly from the classes first. All right, then I use another variable called temporary instance to instantiate based on the name of the name list, all right, and the age. Okay, and once I have this instance available, I can now append it onto my animal list. All right, so this is me breaking into chunks of variables. And as you can see, it is actually easier to read when you have three separate lines, right? As compared to what I've written earlier, right? This can be as short as this, right? I can just do animal underscore list dot append, all right, bracket random dot choice, bracket class underscore list, all right? And after you get a random choice, you bracket your name underscore list, square bracket I, and then comma dot age random dot rent int 10 to 20. Now, yes, you can cut everything short into a single line like this, but does it make it more readable? Right? If your answer is no, it is not readable, then you make it into this form. Right? You save things in chunks into variables first, then you append accordingly. All right? So always ask yourself this question, is it more readable this way or not? And of course, if the idea is you're going to work alone, all right, and you don't care about readability at all, by all means, go ahead. All right. Okay, so this is the idea of object-oriented programming, right? So you can create a lot of different objects by using the same classes, right? And they are all different, right? As you can see, my Abe, Bob, Kate, Derek, Elon, Fran, they are all different. Just because they are of the same type doesn't mean they are not different, right? Just like me and you, we are all human beings, right? But me and you have different names, we have different age and stuff, right? So that's how class and instances kind of work in Python. Okay, all right, cool. You're welcome, no worries. Okay, so, and not only have I shown you the idea of object-oriented programming, I've also shown you the idea of packaging your files, right? So imagine this, you can actually put in your code in a separate file and you import it and you just use the functions that has been defined over there. Okay, so in this case, on your main file, you wouldn't see codes like DEF or class, right? Because all this has been defined in a separate folder. We just import it over as a package, okay? And with this rough idea, you would have known that all your import random, all right, your import time, this just means that in your computer, when you install Python in the first place, you have a file called random.py. Okay, and you have a file called time.py. These are what we call built-in modules, right? It's available there for you to import. However, sometimes you may want to use modules that are not built in. Yes, Jacob, I can scroll down. Give me a moment. All right, this is the entire code. All right, So sometimes you will need to install your own packages, and installing your own packages sometimes require the pip Python package install package is Python installer package, something like that, right? Pip install and followed by the module name. All right, and there are quite a fair bit of Python modules that you need to install before you can do more sophisticated stuff. All right, so just to give you a brief idea, all right, currently we are doing a lot of import time. Yep, time is one of the module. How do we view those built-in modules as in random, math, and stuff? Okay, now time you don't need pip, but other modules you do need, right? So to view all the built-in modules, what I usually do is I will just Google it. Built-in modules in Python. Ta-da! The power of Google. Okay, so this is all the modules that's available to you. And trust me, right, you don't really need most of this, all right? So the 80-20 rule applies here, right? 80-20. Okay, what do I mean by 80-20? You will only use 20% of this module 80% of the time. Okay, most of them are not very helpful for you. Okay, there's a lot of different modules, right? Not only Selenium, you also have your pandas, your NumPy, um, your beautiful soup, if you want to script HTML files, right? Yeah, there's a lot of useful modules that you can explore in Python. And one that I actually found quite fun to play with is this. Okay, I'm going to show you something that I've done. Excuse me. So I've actually found, actually not me, right? My team found out that there is this module called Simple Gui that allows you to create your own GUI, right? So what's a GUI? A GUI is a graphical user interface, right? Something that user can click and maybe drop and stuff, right? And to play with, okay? So all this while, as we have been programming, we have just run it and it runs on the console, right? This is what we call the back end. Okay, I'm sure Mr. Eric has told you guys yesterday, if any of you have attended to his class, right? There is this back end part of the programming, right? We are only doing on the back end, all right? To present to our users, we need a front end, okay? And Simple GUI is one of those modules that can present your program in the front end. Okay, so when I run this, okay, it will install my Simple GUI for me. And just give it a bit of time to install. I was actually going to copy my code. I can actually copy my link to you guys if you guys are interested. Okay, I can share this with all of you. All right, it's open source public, so it's perfectly fine to share around. Okay, so it has been installed. It's going to run now, anytime now. Okay, so this is the front end, right? Where we can see our hangman game, all right? So if you're doing this on your computer, all right, you should see this as the window that pops out. But because we're using Replit, all right, it doesn't pop out, right? Replit just kind of simulate the idea of it popping out, okay? So this is the game that we have done on Hangman, remember, all right? But back then, it has only been on the console, right? It's at the back end. But currently, we are using it on the front end, where we can actually put in some words that say L, guess, all right? If it wrongs, it will change the image for me, right? 6 letters from ship, okay. O, I don't know. Oh, there is O. Q. Usually shapes have these weird names. M. Oh no, what shape is this? P. Okay, I guess I'm bad with shapes. Okay. R. The correct word is cuboid. Okay, what's a cuboid? So I'm hanged, right? So when I click on exit, it will close the program. Okay. All right. So this is one of the modules that you can use to present your back-end program onto the front end. Okay. To learn more about Simple Gui, you can refer to these documents over here. Pi. Oh, this one. Okay, I'm just gonna share this with you guys. Yep, you can fork it. Feel free to fork it. Okay. What else? Besides Simple Gui, Pygame is another one that you can present your program on the front end, but it actually generally helps you to create a game. And okay, let me see. What else do I have? So I have classes, instances, attributes, methods, Dunder, packages, front end. I can actually introduce a few more things on Dunder, but I think that's quite good enough for now to not confuse all of you. How about public, protected, and private classes? Import is called packaging. So the idea of you having an assets.py, this is like a package, right? You're packaging your code. And when you import something over from this package, this is you doing some import. This is not called packaging, right? When you're doing this is packaging, right? When we write everything inside a single code. So yeah, public, protected, and private classes. I don't think it applies here on Python, or at least I'm not aware of it. Okay. Advanced stuff. Okay, so if you're interested, you can click onto it and have a look at it. All right, I'm not going to go through public, private, and protected modifiers. We're not going to talk about decorators and stuff. Okay, so the general idea is you only get 4 tries. You have 5. You have 5 tries. The 5th try, when it's wrong, you'll be dead. I forgot to add another picture. Did I? I thought I have all 5. Okay, let me try that again. Okay, so this is the first picture, right? Okay, countries, full name. Is it Mali? No. So this is the first wrong image, right? Oops, there is an A. Okay, this is the second wrong image. The third wrong image. The fourth wrong image. And the 5th wrong image. See, I have 5. Well, it depends on how you want your hangman to be. Okay. Actually, I think that's about it for today. Even it's shorter than 2 hours, right? But you can use this time to explore around your classes, right? But I don't think you really need to know much about protected private or public classes, right? That's not super important as far as I'm concerned. After the head, the computer will print the body and the hand automatically. Yeah. Usually I don't want to, I mean, for hangman, I just want it to be 5. It depends on your preference as well, right, Braden? If you wanted to have 6 tries, you can do so as well. Okay, you can make your own changes. Yeah. And Simple Gui has a cookbook. And usually how I learn is I actually refer to the cookbook. Let me just share with you on my learning journey for Simple Gui, because I'm actually learning this recently. I have not really touched on this much. There is a cookbook. And what do I mean by cookbook? That means they have several different projects that you can refer to. It's lagging. Okay, sorry. That you can refer to, have a look at it, and see what it actually does. All right, and then you copy it over to your own code editor and make some changes to see how it changes things up. All right, so this is actually the quickest way to learn about a similar, how do you say, to learn about a module, right? Let's say this is the first time of me using this Simple GUI, right? So I want to know how to create a window, right? I'll just do this, copy over, and then I explore around. Oh, and then I realized that, okay, so basically the layout is actually a nested list, all right? And within this nested list, you need to identify your components, right? Because for a graphical user interface, you need to identify what are the different components over there. Is it a button? Is it an input? Is it an image, all right? Or is it just a line of text, right? Then you have sg.theme that changes the theme of the window, right? There's a lot of different color that you can change on the theme, okay? And there is an infinite loop that keeps running to check for your user input, right? Whether you click on the close event or whether you click on exit, all right? Or is it you're clicking on the read, okay? So Simple GUI is a bit confusing because each and every component is linked to a key, all right? It's like your dictionary. Okay, so when you want to update a certain key, you need to tell the computer that, hey, I need to update window square bracket output. All right, I'm referring to this key over here, and I want you to update the value. Okay, exactly what I'm doing with my hangman over here, if you realize. Okay, so when I click on the event that is guess, all right, this is the guess event. All right, I will need to update my input to empty string to show that there is empty, to clear the input. All right, and I need to check if the input is an alphabet and the length is equals to 1, then I will call the function to check my hangman. Okay, by right, this definition should not be here. It should be on my different file as well. Remember what I mentioned about how the main file should not have anything that defines a function or a class. All right, I should actually put this somewhere else. Okay, but just for demonstration's sake, I will put it inside here because the total lines in the end is about 50 odd. It's not too bad. Okay, usually you want to keep your number of lines to within 100 if possible, right? If possible. How do I import a function from a separate Python file? Okay. All right. Maybe we should just do this. Okay, let me just go back to my repo. Okay, let's clear the understanding one at a time. Okay, let's clear on namespace first. Let's say, for example, on my farm over here, okay, I have a new definition of function. Let's call this func1. Okay, and it doesn't require any input. It just says print hello world from farm.py. Okay, So this is a function that I've defined in farm.py. If I were to call this function from a different file, okay, because I have actually imported farm, I can simply do this, right? I can just do farm.func1, all right, call it, and this is me calling my function from a different file, right? But of course, okay, some of you are a bit confused about the namespace thing, right? So let me just do it this way. If I have from farm import star, okay, and then I define func1 again, all right, and this time I say print goodbye world. Okay, so when I print func1, right, I would expect goodbye instead. Now, why is that so? All right, because even though I've imported my func1 from farm, all right, when I define it, I've actually replaced it. Okay, so this is what we call by namespace pollution, right? The namespace of func1 has now been replaced. It has now been overwritten. All right, get the idea? It's like you using the same name twice. That's what we call namespace. Okay, cool. Great. All right, now I have nothing new over here. Or maybe I just talk a bit more about front end and back end. I'm not sure if this is interesting to some of you guys, but I guess I'll just talk about it anyway. So yesterday when Eric is teaching, all right, he mentioned something that he is a full stack developer, right? So some of you would have known what's a full stack developer, right? For those who are not aware, a full stack developer is in charge of both the front end and the back end. So this is a full stack. Okay. What's the front end, right? The website that we're looking at right now, this is your front end, right? The things that you can see, can touch. The back end is the things that show all this behind the scenes, right? How does it work? Why do I have to, okay, why would I type something and something will show, right? Those are usually at the back end, all right? And the back end is where you actually have a lot of dealing with the database and so forth. Okay, this is where you get all your database and stuff. All right, currently when we are saving this is automatically gotten from like the Replit database, right? When we are doing our own project, we may have to assign our own database, right? Either on the cloud, on DynamoDB, or your own hard disk drive, right? You can save local files, no problem, but you have to be aware of this, okay? If you are hosting a website that based on your local files, all right, you need to make sure that as long as the website is hosted, your computer is turned on, all right? Because the moment your computer is turned off, the front end cannot access your local file anymore, right? And then it will crash. Okay, so that's the bad thing about having local files as your database, right? Usually we will want to use the cloud because cloud is usually 24/7. Now, why do I use the word usually? Because your cloud also need to undergo maintenance, right? So there are server maintenance, and those are the downtime that we need to factor in. Okay, but besides those downtimes, all right, it will usually be up most of the time. All right, and yep, that's full stacks. And I am not a full stack developer. I am not good at front end. All right, I am more interested with the back end. And there are people who are like that, and it's perfectly fine, right? So if you're good on the front end, good for you, right? Then focus on being the front end developer. Okay, for some of you who are not so good in the front end and you're more interested with the back end, then just do the back end. All right, it's perfectly fine not being a full stack developer, even though a lot of the companies are looking for full stack developer right now. Okay, so yep, I hope that gives you a bit of an insight. And in Python, if you want to move on to the web development, which I am currently researching into how we can do that, you can look into modules such as Flask and Django, right? So I'm trying to explore this for now to create a server, right, to create a Python-based server instead of using the Node.js. So for those who are going to continue this training camp later on with Mr. Eric, right, in the future, where he will teach about HTML, which is yesterday class, JavaScript and CSS, eventually he will touch on Node.js as well, right? It's JavaScript, but it's for the server. It's for the back end, all right? The current JavaScript that we are looking at, this is for the front end. So there are two different types of JavaScript, right? Even though they are JavaScript, there are two different types. Okay. So I hope that answered most of the question. Now feel free to fire off any questions because I think the session is about to end soon. Node.js. Yeah, just let me see if I have any project I can show you based on Node.js. Okay, I am going to find out. Tkinter. Yep, Tkinter is fine as well. The cool thing about Simple Gui is it's actually a combination of Tkinter, PyQt, and some other GUI modules. Even though it's not a full-fledged module, it's actually easier to use than Tkinter, right? Because it's based on a idea of how do you say it? It's based on the idea of event, right? Where it constantly checks for any event, right? There is a infinite loop inside. If you're using Tkinter, you may need to be exposed to something like the callback functions, right? There's a lot of callback involved. And usually for beginners, callback is quite confusing. What are callbacks? Callbacks are functions that you can use as an argument. That means it will only activate the function when it is needed. Yes, Flask is for backend. Flask is for creating a server. Do you use SQLite DB? I don't. I don't use SQLite DB. No, I don't use SQLite 3 database, so I can't help with that. I'm so sorry. Yeah. There is no callback in the farm example. So let me try to show a simple callback example to see if that actually works this way. Let me try to come up with something. So let's say maybe define func1. I will pass in maybe func2. Okay, so func2. And then I will just define func2 as print hello world. I think this works. Let's try out func1, func2. Yep. So it's kind of like this. So usually what I can do is I can also do while count. Okay, let's say for example, count is equals to 0, import time while count is less than 60, count plus equals 1. If count equals to count divisible by 2 is equals to 0, do func2. Okay, then I will do a time dot sleep 1. Just some random function over it. That means when I call my function 1, it's going to start as counter, right? And this counter is going to increase all the way up to 60. And when the counter is an even number, it will activate hello world. All right. So let's do this. Yep. So this is the easy idea of introducing callback. And in fact, this callback, you can even pass in some parameters that you can pass into this function over here. All right. Let's see, maybe I passed in, let's see, text. Print text. It's fun to count. Yep. So this is like a callback. All right. I have a function that I use it as an argument, as a parameter, right? And it will pass in accordingly. How about count with the same line, just like timer? Don't quite understand your question, Torres. Count with the same line. I still don't quite understand it. I'm sorry, Taurus. He doesn't want to skip to print on another line? Oh, as in to clear it? Oh, okay. I remember Braden talked about something like this before. You need to clear it. I think you need to import a replet. Okay, let me try this. I haven't tried this out before as well. Okay, so let's do this. Replet clear console. Import replet.clear. Okay, can. Let's do this. So let's import replet. Okay. So I am going to clear this first. So let's do a countdown timer, right? For I in range, countdown 60 to -1 to -1. All right, and I'm just gonna print count. Sorry, I still need my time. I realize. Okay, print time left I, and then count time dot sleep 1 replet dot clear. Okay, let's see if it works. Okay. All right, it is installing the Replit package. Okay, it has now been added. So usually when you import something, if the package is not readily available in the system itself, you will need to do some installation and updates, right? So it's taking a bit of time. Okay, so let's see if it works. Ah, it works. So every time it is being activated, it will do the replit.clear, which clears the output, all right, and then it'll be on the same line. You're welcome. Nice. Okay, so yeah, I mean, times like this is like, I'm going to demonstrate on how we can actually use Google to our advantage, right? Like I have not tried this before, but because we have managed to actually search up a solution to this, and we can just give it a try and it works, right? So, yep, power of internet, okay? Yeah, it clears the entire window, that's correct. So if you have any message that is before this, right, you will also need to retype it. Boom, gone. Yep. So I would leave this room up for maybe about 5 more minutes or for questions. Okay, and then we can call it a day so that you can go for your lunch or your breakfast if you haven't had one. All right, and stuff. All right. I'm just gonna stay put for a while more. So that's the end of Python Chem. We can just do a quick recap if you're interested. So we have different data types, such as your string, integer, float, and Boolean. Okay, and we can write conditional statements using your if keyword, right, followed by a condition, followed by action. Okay, and you can add in different conditions like this, like condition 1, action 1. You can elif, condition 2, action 2. Right, this is if you want the computer to perform different actions, right? And you can also add in an else, which tells the computer to do something even if all the condition has been failed, right? If all the condition ends up being false, right? Then you will also have your while loop. Okay, while condition is true, do action. Okay, now when do we actually use while loop? It is when you want to create a loop for a computer, but you don't know when is it going to end. All right, you only know the condition for it to end, but you don't know when is it going to end. All right, you use a while loop. Okay, however, if you know how many turns you're going to use the cycle, all right, my recommendation is use a for loop. Right, for I in range of the number that you want, and then followed by the action. This will perform the action for a number of times. Okay, that's for your range function. Okay, and since we're at the range function, let's talk a bit about range. Right, so if you do range 10, this is gonna give you a sequence of number from 0 all the way to 9. All right, it is up to 10, but not including 10. All right, so if you do range 5, comma 10, this is telling a computer to create a sequence of numbers starting from 5 all the way up to 10. Okay. However, if you tell a computer to do this 2 to 10 to 2, all right, it will start from 2 with a step of 2. Okay, so you increase by 2 every single time. Okay, this is you creating a different sequence of numbers. All right, so range you have 1 input, 2 input, or 3 input. Okay, depending on how you write it. Okay, if you look at the documentation, you will see something like this: range bracket start equals 0. All right, and then you have your n and your step equals to 1. Okay, this is a bit funny because we say that when we define a function, we cannot have a default value before a non-default argument, right? But because this is a built-in function, Python say can, that means can. All right, this is a bit weird for range. Okay, so not only is it for range, it's the same for your slicing or argument as well, right? If you remember your slicing operator, if you do, let's say for example, a string, I have string. Okay, if you do string 1 slice to 2, that means you are slicing all the way up to index number 2, right? 0, 1, 2, okay, up to here. You will get something like this. Okay, if you indicate the starting point as well, right, then you do 1, 2, 3, 4, which gives you TRIN, right? It will not cut up to 5, right? It will just cut up, sorry, it will not include 5. It will just be up to 5, okay? However, if you do this, all right, okay, if you don't indicate anything, it is 0 by default. If you don't indicate anything, it was the n by default. And if you indicate the third input, this will be the step, right? So this is going to be your 0, 2, 4, right? SRN. Okay, so this is slicing. You can slice the strings. You can also slice list. All right. So just a quick note about list. You use square brackets to create lists, and a list is important in terms of its index number, right? The elements are ordered. So you have 0, 1, 2, 3, 4. Okay. To access a certain element, you need to index the correct index number. Okay, let's say for example, you want to access the third item, you need to do this 1 square bracket 2. Okay, in contrast, if you have a dictionary, all right, a dictionary is stored in a way that it is not related to its index number. However, it has a key to it. Okay, a key and a value. All right, key and value. Okay, so to access something that's in a dictionary, you need to refer to its key, like this. Square bracket, key. Okay, the key difference between a dictionary and a list, right? List, you need to refer to its index number. A dictionary, you need to refer to its key instead, right? Biggest difference between these two data structure. And then you have your definition of function, right? So we define a function using the def keyword followed by your function name. Okay, and then you have your parameters, right? Depends on how many parameters you want for your function. Okay, and then inside your body, you need to have the action, right? What do you want to do when this function is being called? Okay, remember your indentation as well. That is being achieved by clicking on your tab key. All right. Defining a function and calling a function is different, right? Defining a function is you telling the computer that, hey, I have this function available, all right? When it is being called, do this, okay? But when you define it, nothing's gonna happen, right? If you want a computer to do something, you need to call the function, right? The word here is call the function, all right? So similarly, you can also define your own class. All right, but class name you need to use Pascal case, right? That means the first letter of each word is capitalized. This is how we name our classes. Okay, so this is how you define a class, right? The first thing you need to do is define your constructor, right? It will always have the self parameter. Anything that is inside the class definition must always have your self, right? This is referring to the object that you're going to create when you instantiate this class. All right. Okay, and then you can introduce your attributes over here. All right, and you can also define your own methods. All right, just like how you define a function. Okay, and these methods will only be available to this particular instance, right? This class, right? When you instantiate it. Okay, and when you want to extend from this existing class, okay, let me just rub all of this. If you want to do an extension, you can just do a class, let's say class name 2, right? And then you extend from your class name. Okay, and if you really need to define, if you need to add on additional attributes on top of the initial init, you need to do a def underscore underscore init underscore underscore self. All right, followed by your super dot underscore underscore init underscore underscore bracket. All right, this init is actually referring to this particular constructor over here. And this is where you add in your additional attributes. Okay, if you don't have this init for your class name too, all right, you will still be able to get this from class name, all right, by normal means of inheritance. Okay, however, if you want to extend, right, this is you extending your class. You add new stuff to your classes, right? And that's usually what we want to do when we introduce a new class, right? We extend the current class by a certain degree, right? Add new attributes or maybe add new methods to it. Okay, so that's that. All right, I am going to look at the chat. Could you post your past replet links here? Sure. What's the equivalent from, what's a whiten to replet clear? I am going to go to my repo. If you're gonna clear it on your IPython, I think you can use an IPython.display. Replit.clear. There's another module called IPython clear output. Yep. This is what I use to clear the output of my Jupyter notebook when I'm using Jupyter notebook. And I guess it really depends on what you want on your, what is on your IDE. Okay, my past repos. Okay. Day 5. Oops. How do I actually get the links? Okay. Day 5. Day 4. Day 3. I'm not sure. You guys can try to click on the link and see if you can actually look at my code. I'm just trying this out because I'm lazy to click into one of the links one by one. Yep, sure. All right, that's the end of